Okay, question 10 asks us to, you know, not do much, right? We've got a set of data here, some x and y's, and we're supposed to plot this data and then generate the least squares regression line. I'm not asking you at all to consider residuals and whether or not a line is a good fit. In fact, I'm not even really asking you to look at the correlation coefficient or the coefficient of determination. I just want you to just mechanically show me that you can still enter this data and generate the least squares regression line, and then use it to predict a value out in the future. So rather than have you sit here and watch me plot these points, I'm just going to go ahead and pause the video and magically plot them all right at once. So you can see that there were 8 data points to plot. Actually, let me check. 1, 2, 3, 4, 5, 6, 7, 8. And I plotted 8. 1, 2, 3, 4, 5, 6, 7, and 8. And clearly I see, let's not make this a permanent mark or anything, but I definitely see what looks like some kind of a pin in through here, right? There's some kind of line that's fitting that zone. So that's what we're going to set up to find that least squares regression line. So let's bring our calculator over to the screen, and we're going to go ahead and review how it is we generate the least squared regression line with our TI 83 or 84. I'm going to drag this way up to the top there. So I think we can, well, we can't quite see the bottom buttons, but that'll be okay. First thing we're going to do, of course, is, as always, is turn on our calculator. And it's not wanting to turn on again. Okay, there it is. And in order to enter our data, we're going to press Stat, and then we're going to go to Edit. And right here we are. So we're ready to enter our data. And fortunately, I've got a keyboard. So I'm going to enter all the x values first in this first column. So I've got a 3, a 3, a 4. Oh, that's not working. Well, it looks like the keyboard doesn't work anymore for this calculator. Okay, well, let me go ahead and enter it on the calculator's keyboard. I've got a 3, a 3, a 4, and then I've got a 3, 5, 2, a 3, a 3, a 5, a 2, and then a 6, and then an 8. Oops, I missed the 6. No, not 86. A 6, and then, are you kidding me? A 6, and then you should be an 8. So that was scary. Let me go back up here because I got to make sure. It's important that these values are correct, because if they're not, I'm going to get the wrong least square regression line. So just reading them back, I see a 3, a 3, a 4. And then I have a 3, 5, 2, 6. Let's see, 3, 5, 2, 6. Yeah, and then the final value there is an 8. Okay, so I'm now going to move over to the second column, and I'm going to enter the corresponding y values in list number 2. So I've got y is an 8, enter, and then I've got y is a 5. And then I've got a 7, enter, 6, enter, 11. And that was a 1. This would be 11. Then I've got 3, and then 9. And I have an additional 11. Okay, and again, I'm just nervous about it, so I'm just going to read them back to myself. I've got 8, 5, 7, 8, 5, 7, and I've got 6, 11, 3, so 6, 11, 3, and then I end with a 9 and an 11. By the way, I really, try to be just this careful because I know just one little thing, can throw me off. So I'm trying to model the level of precision that I think that we should all bring to bear. So the data's in here. We're ready to generate our least squared regression line. So I'm just going to hit stats again, and this time I'm going to calculate, and I'm going to go down and calculate linear regression, which is option number 4. Oops, not 5, option 4, and I press enter and enter again. Now this says that y equals ax plus b, right, is the form of the equation, where a is 1.2 and b is 2.4. So my least squared regression line is exactly that equation. So I'm going to go ahead and write y equals 1.2 times x, and then plus a 2.4. So the instructions did say draw the least square regression line on the graph. It's a little tough, right? But my y-intercept is slightly, it's actually between 2 and 3, almost 2.5. So I've got, right here's an intercept. And then I'm going to go up 1.2 and then 1 unit to the right. In fact, if I think about that, I think if I go over 8 units to the right, that 0.2 would become, or it would be a 0.5. No, if I went over 5 units to the right, that would be equivalent to 5 times 1.2, which is 6. So at 5, I should be hitting the number 6, according to this line. That doesn't look right. That looks definitely small. Oh, no, it would be 6 plus 2.4, so 6, 6, 7, 8, and then 0.4. So that's it right there. So with those 2 points, I'm going to go ahead and just grab the line tool and draw the line that goes through them. So I'm starting here and just hitting that point somewhere in there. And I gotta say that that does not look right to me at all, because here's my concern. I've got 1, 2, 3, 4, 5, 6 points above that line and only 2 points below it. And if it's the least squared regression line, I think I could do a better job than that. And actually, when I went through and I plotted that point, that really is the regression line. That was y equals exactly what we said. 1.2 times x plus 2.4. So the problem is how I sketched it. You can see I'm off from these points up here. The final question there says, hey, when x is 56, what's the generated y value? So I'm just going to evaluate this function for 6. So this is going to be that this equals 1.2 times 56. And to that, I'm going to add the number 2.4. So let me grab the calculator, free it up here. So when I take the 1.2, multiply by 56, and add 2.4, I get 69.6. So when x is 56, I would expect to see about 69.6, somewhere in that range in my data set. Definitely on the line right there.